Hello, ma'am. Hello. Hello, ma'am. Am I audible, ma'am?
Yes, sir. Good afternoon, sir.
Hello, ma'am. I'm audible. Hello, ma'am. I'm audible.
Yes, sir. Yes, sir.
Yeah.
Am I audible,
Yeah, yeah.
sir?
Yes, yes, yes.
Audible, sir?
Yes, 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 madam. You're audible.
Okay.
Hello, ma'am. Hello, I'm audible, ma'am. Hello. Hello, ma'am.
Yes, sir. Yes, sir. Yes, sir. You're audible, sir. Am I audible, sir?
Yes, madam. You're audible. Thank you. Sorry. Can okay? It's can okay, then I'll see from there. Don't need after. And don't need after. I can right.
So for this power, do we need to consider limit?
Good afternoon, sir. Good afternoon, Anna ma'am.
Hello, sir. Your voice is a little bit low. Hello, Puneet, sir. I am audible, Puneet, sir.
Yes, sir. Sir, am I audible, sir?
A little bit voice is low. Increase the volume.
Now, sir?
Now it is
Now?
okay. Now it is fine.
Thank you. Thank you, sir.
हाँ दिवेंद्र Hello, Namaste, teacher, sir. Namaste, sir. How are you, sir? Am I audible, sir? I think you are muted, sir.
Oh, sorry. Yeah.
Yeah. Sir,
I
namaste,
think
sir.
my microphone was on.
Yeah,
Namaskar.
namaste, sir. Namaste. How are you, sir? After a
I'm
long
doing
time.
good, sir.
Yeah,
And how are
after a
you?
long time, probably after 3-4 years, I'm seeing you.
Exactly. Yeah.
3-4. I probably 4 years back we had met, right?
Exactly. Yeah,
And,
that's right.
Yeah. So nice to see you, sir. After a
Yeah.
long time.
Nice to see you too, sir. Yeah.
Very happy to see you, sir.
Yeah. Same here.
And I'm very thankful that you had taken a time out for our students. Sir.
Yeah, I'll be fine.
Yeah. Sir, we'll start at exact 2 o'clock to probably
Mm-hmm.
2 o'clock.
Sure. We can do that. Yeah.
Sir, now it's work from home? Work from home?
Yes, for the past
Sometime,
2
yeah.
years, I've been working from home. Now since the situation is getting under control, it seems that we'll have to go back to office. So it's kind of 2 days work from office and then remaining days work from home. So yeah.
Please do visit sometime our university,
Sure.
sir.
I will. Yeah.
With Joanna.
Yeah. I will. Yeah.
Oh, nice. Sir. I'm very glad to see you, sir.
Yeah.
Very happy.
Likewise.
Delighted. Hello, Puneet, sir. I think Nandini madam is also there. Nandini madam. My dear students, start joining soon. We will be starting a lecture. Please log in fast and keep your mobile on muted mode. And it's quite an interesting topic, sir. PLM and all these things very much required, even though we are reading IoTs and all these things. But about PLM, we are not much aware. Yeah. So awareness will be created among our students.
And I think it's also my privilege to present this to DSU. So
yes, sir. We are grateful to you, sir. We are. Puneet, sir. You please put one message.
Yes, sir.
We'll be starting at exact 2 o'clock.
Sir, I have dropped the message, sir.
Yeah.
I have dropped the message. One thing.
Anna ma'am, can we start, ma'am?
Yes, sir. Shall we start, sir? Vedika?
Yes, yes.
Vedika is there?
Yes, ma'am.
Yeah.
A very good afternoon and a warm welcome to everyone who have joined the webinar for today. I'd like to introduce today's presenter, Mr. Tejo Thomas, who would be speaking about the topic, the road to product lifecycle management and lasting impact on industrial IoT. Thank you, sir, for taking your time to join us today. And thank you for all the teachers for joining the webinar. As we all know, industries of the future are all about people creating the products that shape our lives. IoT helps in manufacturing by improving processes, and also the bar for high-performing smart manufacturing organization has never been higher. Connecting people, places, machines, and devices with these innovative technologies will also allow us to harness operational and business data for efficiency control and improved customer satisfaction, which is one of the biggest benefits of IoT. So now I'll be giving it up to our chairman, Dr. Vaibhav, sir, to address the session.
Yeah, thank you. Thank you, Vedika. I welcome Mr. Tejo Thomas, Senior Business Analyst, T Connectivity. I also welcome all the participants. I welcome our Dean Sir, and I welcome our Registrar Sir. I welcome our Vice Chancellor Sir in their absentia. My dear student, today's lecture, The Road to Product Lifecycle Management and Lasting Impact on Industrial IoT, is a very important and very useful lecture, because the IoT may have the power to transform the industrial sector, as we all know, but need to understand the changes posed by product life cycle management on connected technology. My dear student, because with the power of the PLM, manufacturer can improve the efficiency of each phase of the product life cycle by incorporating the strategies, planning, management, and execution. But what are the challenges that are posed by PLM that Mr. Tejo Thomas will be updating us in our today's lecture? I request all the students to note down the points that Mr. Tejo Thomas will be mentioning in his lecture. And as you are aware that you need to submit the reflection notes for the webinar that will be given by Mr. Tejo Thomas. I also request my dear student to be muted during the presentation. And if you have any questions, please put it in the chat box. Please put it in the chat box. We'll try to take the questions at the end of the webinar. I once again welcome Mr. Tejo Thomas sir for his sparing his precious time, and above all his precious knowledge he's trying to share with all of us. We'll make the best use of the presentation, and we'll try to see that how this type of things can be helpful for our society, how this can be helpful for building up the projects, and how the product life cycle management and all is affecting. So I will request I request Anna ma'am to take over the session. Thank you, Anna ma'am.
Thank you, sir. Vedika?
Yes, ma'am.
Yeah.
Now I request Puneet sir to give the introduction of the guest.
Yeah. Thank you, Vedika. So, as our chairman has mentioned, that Mr. Tejo Thomas is a senior business analyst in TE connectivity. So, with this vast 14 years of experience in the field of product lifecycle management and product development, he has worked in various domains, or he has brought solutions or provided solutions across the domains like aerospace, automotive, heavy machine, and healthcare. So he has handled multiple projects in enabling PLM solution to business. So his projects include windmill PDM link implementation, scaffolding and tool design for Vouch Aerospace, business administration in Windchill PDM link and Windchill product link. So he has conducted training and broadcast spearheaded operation to enable business units to transition smoothly into a digital work platform. Prior to this, he was working with Wipro, SKF, and Scient in various positions. And Mr. Tejo Thomas is mechanical graduate from NITE Bangalore and pursued his executive PGDM in international business from Alliance University. He is also a certified project management professional. His article on communication change management, the IoT way, was approved by PTC to be presented for PTC Live Works 2016. He also published a paper on consumer behavior towards global counterfeit products in the proceedings, managing library and information system in digital world, challenges and opportunities, held in the conference ManLibNet 2015 at TAPMI Manipal. Thank you, sir, for joining today.
Thanks a lot, Puneet.
Thank you, Tejas.
Thank you, sir.
So, shall I start the presentation?
Please, sir. Please.
All right, yeah, I'll do that, yeah.
Thank you.
So, I'll start sharing my screen. Can one of you confirm if you can probably see my screen?
Yes, sir, it's visible, sir.
All right, perfect, yeah, sounds great. Once again, I mean, thanks a lot, Puneet, and thanks for that introduction. First of all, I'm really, privileged and honored to be a part of this discussion. I remember my days when I was actually, when I was doing my engineering back in 2008. We used to have sessions like these, where an expert from the industry would basically visit our campus, and they would give a session on the latest emerging technologies or the work what they actually do, and these would basically provide a very and a very good insightful thoughts for us, so that because this is a stage where we normally look into our next phase of life, right? We would we are actually done with most of our studies. And then we would actually think of either going to a new place of work or for the higher studies. So this is a place where you can actually decide as to where exactly you would like to get into. So I would say that these type of sessions are kind of quite valuable to you, and you can actually make the most out of it just by trying to decide as to where exactly you would like to see yourself in the next couple of years. All right, so what I would be doing for the next 1 hour is I will give you a brief introduction about PLM. I think, since I have close to 14 years of experience in the field of PLM, I think I might be a little bit eligible to let you know on the concepts of PLM. And I can also, answer to some of your questions or queries that you might have. And then, let's try to take it that way. And we can also try to make this session more, more interactive in that sense. If you have any questions or concerns, please feel free to drop in your comments in the chat window. And then I shall try to have that addressed at the earliest. And in the presentation, you can also find my link to my LinkedIn profile. So we can also connect, I mean, even after the session is completed. If you'd like to know more about PLM, if you'd like to know more about the career prospectus on, what are the different areas in which engineers can actually contribute in the field of PLM, just let me know, just drop me a chat, and then I will try my best to answer all your questions or queries. All right, so I know this is an afternoon session. It can get a little bit boring, but this is most of the afternoon sessions when I was doing my engineering, I felt it was a little too boring, to be honest. But let's try to make it as interesting as possible. And then what we'll do is maybe we'll just start off by doing a situation play where I will give you a situation. Or a situation where which basically had the origins of PLM. So I would basically start off with a problem statement, so you can basically think about or ponder upon the problem, and then think of on how we can actually solve those problem statements. Yeah. So that is something which we will be looking into, because this is how I typically do it. For any presentation that I do, even within my organization, or for any broadcast that I actually do, I normally start off with a problem statement, because that is something which most of the attendees had actually found it to be interesting. Because if you directly try to jump into the concepts or the idea, then people might get a little bit lost, right? So what I will be doing today is, let's try to take it at the grassroots level. We will try to understand what the problem is, and then we'll try to compare it to the technologies that we have today, and that would basically transcend into the definition of a PLM. So by the time we complete with the situation play, I'm sure that you will have a fairly good understanding as to what PLM is. Even before me trying to define what PLM is, I think you would have a fairly good understanding of what PLM is all about. And then we will also try to take a look into the life cycle, because that's the most important thing with respect to product development. Yeah, we'll try to take a look into that, the different life cycles with respect to a product that basically goes through. Basically, it matures from a state of concept to the time when it gets discarded, much similar to a human life cycle. So we will also take a look into that, a deeper dive into the life cycles. And then we will also try to take a look into collaboration. Because, when I talk about PLM, there are 4 or 5 things which basically should be striking our mind. One is people. The second one is process. The other one is the data, security, and then communication. So these are some of the things which, and the last one is security. So these are some of the key elements with respect to PLM. So we will also try to take into collaboration, and then we will also try to think out of the box with respect to the future trends in PLM. For example, if I'm trying to take collaboration for that matter, we can actually think of something called as a metaverse. So we'll also try to take a look into that with respect to collaboration and how teams can actually interact with respect to product development in the initial phase, and what happens if we actually take it to a metaverse. And then we will also try to look into some of the prominent solution vendors that you have in the market. Probably these would be so if you're trying to get into a PLM industry, most probably these would be the softwares which you might be working on. Again, the OEMs would basically prefer based on their business requirement. They will do a selection based on what each of these vendors are willing to offer. So we'll also try to take a look into some of these prominent vendors. And finally, we will try to end this up with a quick understanding on what would be the career perspective in the field of PLM. Yeah. So if you are a developer or if you are interested in the functional side, so what would be your career prospectus in that sense? All right, so I think some of you or most of you might have already Googled to know what PLM is all about, and I think you might have a fairly good understanding. But let's try to like I said, let's try to tackle it from the grassroots level. So what I will do is let's start off with the situation play. Let me just try to go the presentation mode. All right, so what I will do right now is let's just travel back in time, say 1985, and let's just assume that you are actually working for a company called American Motor Corporation. Yeah. So back in 1985, American Motor Corporation, or AMC in short. So this company is actually located in a place called Michigan in the United States. Yeah. So as you can see, back in those days, I mean, just to give you an example, AMC is a company that actually manufactures cars. Again, these are not, AMC as a company is not that big, while compared to that of its, comparing to that of its competitors. So back in those days, AMC as a company had big competitions like Ford Motors, General Motors, Chrysler. So these were some of the local competitions which AMC had. They also had competitions from the foreign players as well, like Mercedes-Benz and BMW. So to keep up in the market, right, it was pretty tough for AMC because AMC was a mediocre company, and then the products was kind of pretty good as well. And obviously, other players were also doing extremely well in the market. So when you're trying to compare, the market share with other companies to that of AMC, AMC was somewhere in the bottom. Yeah. So what AMC thought was probably they should think out of the box and then think of improving the process than focusing more on the product design, because AMC at that point believed that product to them was kind of ideal at that point, because they were giving competitive features, functions than what the others were actually giving. But the lead time what they had was a little too high. Now, speaking about lead time is nothing but the time that it takes to bring your idea to reality. Yeah. Or you have an idea, you basically conceive your idea, try to work on your idea, and then try to produce it, and then try to give it to the customer. So the time duration, the entire span of time is basically called as a lead time. So this lead time was a little too high compared to that of the other competitions. Yeah. So this lead time is a major deciding factor, mainly because if you take an example, what can I say? An example of a company in India, say, let's say BSNL. Yeah, I'm not sure if you're aware of this, but 20 years back, if you wanted to have a BSNL connection, yeah, it would probably take 6 months or even more, close to a year, to get a BSNL connection. So if you get a BSNL connection, there would be a small celebration at your home. So that's how eventful getting that product was. But then at that time, back then, BSNL had the monopoly. There were no other competitions at all. But then there were a few other, things got a little bit different when few other companies actually joined the game, and then they started offering products that you basically order it today. The next week you have the product at your table. So things began to turn out a little bit different, and this was kind of worrying to BSNL. So right now you can see, had BSNL taken a proper approach or a proactive approach in terms of addressing some of these concerns, specifically with respect to lead time, they would have probably on top of the chart. Yeah, so you can see how important lead time is. Yeah, so the moment you actually conceive your idea, the moment you actually bring the product out to the market to your customer, that's a very, very important deciding factor to to improve your business at that point in time. So let's just come back to AMC. So AMC also thought about this. So they just thought of this approach. Yeah, we want to bring a product with the highest quality or no compromise in quality. They also wanted to reduce the cost. They also wanted to improve the process. Yeah. So when I mean improve the process, they wanted to identify the places where there is waste in terms of time, in terms of cost, in terms of effort, so that they can eliminate all those waste and then try to make the process more lean. So right now, this thought process is gradually getting into the thinking of the lean process. Yeah, trying to make the process more lean in that sense. All right, so that's the introduction to the organization called AMC. So assuming that you are the operations head, yeah, and you have been taken back to Michigan, 1985. So this is my office setup. So specifically, I've taken you to the design organization, or back then they were calling this as the drawing office. So drawing office, just to let you know, used to be an endless room with a huge number of drawing tables. You can see the behemoth size of these drawing tables with countless number of drawings. Yeah. So just to let you know on how things work, once you have your idea, you actually put it in a paper. You actually try to run around to your respective immediate manager or any functional reviewers or approvers to get their review or thoughts on the new product. Or it could be a new product, or it could be a revision on an existing product. So they basically will have to carry these drawings, carry documents, any associated documents to their respective managers to get the approvals. And it was a lot of effort in terms of doing all these things. And you can also see the gazillion number of documents that we have here. Each and every table used to have different versions of drawing, different products. So there was a lot of confusion in terms of product design. So if one person is working on one revision of one version of the product, there could be chances that the immediate engineer would be working on a different version of the project. So back in those days, errors were a major contributing factor to cost, because if there is an error, it can be directly, if you want to rectify the error, it can be directly translated as cost. So that's how important it was for them to identify those errors and to avoid or eliminate the making of those errors in the entire design process. All right, so this is the design setup. Given the privilege that you are in 2022 at this point in time, yeah, you have enough of technologies, you have good systems. What would you think could be improvised in my drawing room at AMC? Just pour in your thoughts in the comment window. We shall take a look at that. We'll just go through some of those points. Yeah. So what I'll do is, let's just give me a second. All right. So first and foremost, let's just try to identify some of the flaws. Yeah. First of all, we have too many manual activities. So in the moment when we are actually, speaking about this, identifying the flaws, you can also, try to enter your thoughts on what could be a possible advancement in technology that could have been introduced in 1985. So obviously it cannot be a meta coin or Bitverse or cryptocurrency or anything of that sort. But if you look into the advent of CAD was, the usage of CAD can be probably dated back to 1965. Yeah. At this point in time, since it is 1985, we also had internet. Internet was introduced in 1983, I guess, if I'm not wrong. So we also have an option of using internet because early adopters of technology are the ones who can be, the most successful in the business. So these are some of the hints that I'm actually giving you. Just ponder upon these thoughts. Also try to enter your comments in the chat window, and we'll just go through that. And in the meantime, let's just try to identify some of the flaws in the system. First and foremost, we have too many manual activities, like I just mentioned. You can see each of my engineers in this drawing room is working on their individual drawings, having no idea as to what the immediate engineer is actually doing. Yeah, so there could be possibilities that there are two engineers working on the same drawing. Basically, they are not being notified about the task that these guys are basically assigned with. And again, like I said, if I want to get an approval for my drawing even before releasing my product, I should literally physically carry these drawings to my immediate manager or my supervisor to get an approval. So there are literally too many activities, manual activities in the process. And then, like I said, errors in these manual activities can be quite costly to get them fixed. For example, if I'm trying to work on the latest version of the fender in my car, and I have my immediate engineer who is also working on the fender, but not the latest version of the fender. And then ultimately, I get to realize that there was this mistake. So obviously, we'll have to, in order to get things rectified, it would take, again, a lot of man-hours and cost in terms of rectifying these errors. So too many manual activities is one thing which you can actually see here. Lack of collaboration. You can see each of these people are actually working in silos. There is, a knowledge. If one person has a knowledge on fenders, or one person has knowledge on engines, he is the sole responsible person who will be, fully working on those parts that actually goes into the making of the car. So there is no collaboration at all. Also, with respect to, like I said, fetching approvals on the documents or the drawings, there is no collaboration. If I want to make a new revision on my object that is already released, I should basically get in touch with the stakeholders with whom the product is directly getting affected with. For example, since I'm actually working in a design organization, it would have been good if I can also get in touch with the manufacturing engineer to see how much feasible it would be to manufacture the new version of the drawing or the new version of the object. Yeah. So at that point in time, back then, we did not have that luxury of doing. So literally, like I said, again, this poor chap will hold his drawing. He will go to a manufacturing engineer, discuss the idea on the new revision, and then check if that would really be a feasible solution to be implemented or not. So literally, there is no lack of collaboration. Possibilities of version mismatches, which we just spoke about. Since there is a lack of collaboration, there are a good chance that we end up in working with the different versions of the object. So versions and revisions, if you're not really familiar with, we will certainly discuss that during some of the slides that actually follows. Manual approval and release process, which I just mentioned. If you want to get an approval or release, or again, not just approval or release, if you want to review the drawings or to do a QC of the drawing, you should basically, carry these drawings out to the respective supervisor or the functional reviewer and to get it reviewed. Creating new revisions of the products are very complex and time consuming. So just to let you know on how revisions work, yeah. So be it a new product introduction or be it a new revision, the very first stage would be the marketing guys. Yeah. So what they would do is they would get into the real market. They will do a market research to understand what the consumer actually wants. Yeah. And based on that, they would see as to what the competition has to provide. Yeah. If there is already a competition in place, they would try to.
ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ ಇದೆ ಯಾವ್ದು ತಗೊಂಡು ಯಾವ್ದು ಮಾಡ್ತಿದ್ದಾರೆ
I'm sorry.
ಯಾವ ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ ಟಿಕೆಟ್
Yeah, if there are no questions, I would request you to go on mute.
Karthik.
ಯಾವ್ದು ತಗೊಂಡಿರ್ತೀಯ
Karthik.
Please be on mute. Please be
ಅದೊಂದು ಸ್ವಲ್ಪ 807 306 51
Karthik, please mute. Karthik.
Or can the admins mute Karthik? Okay, perfect. Yeah, perfect. Yeah, so like I said, the first place would be for the marketing guys to do a market research to understand what the market has to offer if it is already there. If it is not there, it would be a new market. New product. Can the admins try to mute?
Anna ma'am, can you try to mute it, ma'am, if possible?
All right, I think it's much better now.
Done, sir. Done.
Yeah, perfect. Yeah, thank you so much.
Thank you, sir.
All
Sorry
right,
for
yeah.
the disturbance, sir.
Yeah, no problem. So, like I said, the initial phase would be to do the market research, try to identify if there is a product that is already existing in the market. If not, try to understand what the consumer wants, and then you basically start off from there. Yeah. So, if a product is, if you're trying to launch a product for the first time, then it would be termed as NPD, or a new product introduction, or a new product development. So even in those cases, what happens is you should basically propose an idea, get an approval for that idea, and then work on that idea, and then have that released. So that's the first part called NPD. And then second, there is something called as a sustaining change or creating new revisions. For a good example of a sustaining change would be, I can say, Creta. Hyundai Creta as a car. I think it was probably launched in way back in 2010 or 2011, if I remember it right. So the first version of the car was launched, yeah, and then back in those days, it was actually matching to the market expectations, yeah. So the company was actually doing well in terms of sales. It was actually matching on par with the customer requirement. And then eventually what happened was new competitions started coming into the market. For example, Kia Seltos, yeah, they just, surprisingly, they just came to our market, and then much better in terms of because if their product ideas is actually leaked out, or it is being it's being destroyed, then the company itself would be in the verge of closure if they really don't have a proper backup plan. I remember when I was actually working for SKF. SKF, to be honest, is a very, very old company. Yeah, it was also there during World War II. So SKF, just to let you know, is a company that actually manufactures ball bearings. Yeah, so they have all these drawings. Yeah, and then since it was back in those days, were kind of prominent. What they used to do was, these drawings were actually placed inside caves. I had the fortunate, I was kind of fortunate enough to, get in front of one of those mountains. Obviously, they are not making use of those caves anymore. So they would basically have all these drawings, backup drawings, placed in a vault, and then they would, place it inside these mountains. There were huge tunnels that were being made inside these mountains only to store these drawings, just so that if a bomb falls on the SKF factory and if they loses out all these drawings, then the chances of a company closure is kind of it's kind of very close. So that's why most of the companies those days would somehow have a backup of these drawings, either placed in caves or in some vault or some undisclosed location. Yeah. Again, if you look into the recent happenings, the Russia invading Ukraine, if this office were to be in Ukraine and if Russia were to invade my organization AMC, if I had all my drawings, these drawings would have been burnt during one of those, when one of the bombs falls into my organization, then I should basically close my organization because I have no idea. All my IP, everything is just lost during the war. Yeah, so that's how important. Chances of, that's how important it is for an organization to secure their data. So that's on a very high level. But if you also look into the micro level, there are chances that people within the organization can also steal this data and then send it across to another organization. So literally, a person walking down the aisle can, take one of the drawing that has been placed in the drawer, and then he can also have the information leaked. So literally, in the organization which I'm actually working right now, there is AMC. In the example, for me, chances of data losses are actually very, very high. And requesting changes to the product is not really easy. So if I want to request a change to my product, so if you're trying to compare the scenario to today, yeah, I can say that, my product, for example, coming back to Creta, yeah, I would say that, as anyone in the organization, I would have the luxury of creating. Can you just give me a second? Hello? Slides are not visible. Okay, I'll just take a look at it. Aren't my slides visible?
No, sir, slides are not visible, sir.
It's not visible.
Yeah, slides are not visible. You can share it, sir.
Yeah, I'll try to share it again.
Please, thank you, sir.
Yeah.
Sir, now the slides are visible, sir.
It's visible, right?
Yeah, but the first slide is there, sir.
I think there's a lag.
Now we had come to first slide, sir, road to PLM. Now that some factory slide is there.
Okay, I'm on the third slide now.
Yeah, we are in third slide, sir.
Third slide, right? All right, perfect. Yeah, really sorry for that. I never thought that actually.
Sometimes it happens, sir. In Google Meet, it usually happens. Slides won't change.
Okay, yeah. And then moreover, I am actually used to Microsoft Teams, so I'm actually
Microsoft Teams. Yeah.
I'm actually new to this application, so really sorry for that.
Yeah, no problem. Please.
Yeah. Yeah. So yeah, coming back to the example, what I was actually talking to you about, requesting changes to a product is not really easy. Yeah. So if I want to request for a change, given the luxury that I have today, I can actually create, anyone in the organization can actually create something called as a problem report. Yeah. So that would basically, highlight some of the challenges that the product might actually face in terms of losing out on business, or it could be also an improvement idea with respect to the product to keep up with the competition, or an improvement idea to improve the ease of manufacturing the approved item. Yeah. So back in those days, requesting a change never used to be as easy as how it used to be today. Because back in those days it was more of a hierarchy approach. We should basically request for a change and then wait for the manager, or the product manager, who is mainly responsible for this. So if he is not available, then we'll have to wait for until he actually comes back. So that was actually taking a lot of time in terms of letting the management know about our improvement ideas. So that is not the case today. Absolutely not the case. Cannot even think of outsourcing, obviously, right? So right now you can see products are created. The drawings are being done on physical drawings, literal drawings. And again, if I want to have a thought of outsourcing these design tasks to my colleagues outside of the country, it's literally impossible. Yeah, either I have to call some expert from another country, or we should basically train the resources within our organization. Or had there been a place where I can have all of my drawings stored in a parametric format or a software format that can be also shared with a resource overseas, I think that would probably help me in terms of the expert knowledge that I can actually receive from a country that has a lot of resource, or also in terms of security, and also in terms of cost. You can see, I mean, live example is the task being outsourced from many other countries like US and Europe, where the labor charges are quite high, to India. One competitive advantage that we in India have is we have a good number of talent, we have good number of engineering colleges, and also with respect to communication, I think we are on par compared to any other countries, or even better compared to a few countries. And also with respect to the tasks that we do, I think it is much better compared to what other countries are actually doing. So and also the most important part is the cost advantage. That's one of the main reasons why companies think of outsourcing their work to a different country. So in this setup, like I said, we can't even think of outsourcing. So this, would basically make AMC think of an alternate approach. Like I said, CAD is already in place. So they were actually thinking of making use or taking the capabilities of CAD and then trying to make, the software versions of the drawing. And then, this is CAD can be also considered as the initial baby steps towards the digital twin. I'm sorry, any questions? All right. So this can be deemed as the initial baby step towards what we term today as digital twin, because back in those days, it was all about dimensions, length, width, breadth, that's it. And then later on, it moved towards even more advanced attributes like materials that are being used, blah, 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 so on and so forth. And then right now, we were not even satisfied with those product attributes. We wanted even more. And then what we try to do was we try to have sensors attached to the physical objects, and then we try to get into the physical environment to capture some of those attribute values, which can also be taken into the digital world. So, when I'm talking about a digital world or a digital, the physical objects in a digital world, these days are kind of, it's kind of 95% mimicking the things that we have in the physical world. So that would basically mean the concept of a digital twin. So we will also take a look into that as well. But just to let you know, these were the initial beginnings of the digital twin. Yeah. And then configuration management. So you can probably ask your parents, I mean, if you were to purchase a car back then, there wouldn't have been much options available. Either it would be a petrol or a diesel. That's it. But if you're trying to consider the variants that you have to this day, I mean, for today, if you're trying to order a Hyundai Creta or a Kia Seltos or any other car for that matter, you can, based on your budget, you can you can opt the car of your choice. That is, if you want to have a sunroof, or if you would like to have some alloy wheels integrated, if you would like to have some turbo engine. So the number of configuration that you have is kind of countless these days. But back in those days, it was only one size fits all was that was the mantra. So there are even more flaws that we as a design head or an operations head can actually identify in the process, in the existing setup. Yeah. Now, like I said, it would be better if I could automate the entire process. Now, right now, what we're trying to do is, first we try to identify the problem statement. It's not really a problem statement, but a series of problems that we have right here in the existing organization. Yeah. And if we were to have some of these points underneath, then I think we can probably have an ideal system. And this would basically translate towards PLM. Yeah. So automating the entire process, like I said, the new product development, sustaining releases. What if there were to be an approach where once after I'm actually done with my drawing, I can send it out to my immediate supervisor or my immediate manager via email communication? Because remember, at this point in time, internet was there. Maybe it is still in its nascent stage, but like I said, since we are going to be the early adopters, we have the advantage of technology. So automate the entire process. One thing is making use of the automated process for any releases, for example, NPD or sustaining releases. Easier integration to upstream or downstream systems. I'm sure back then systems wouldn't have been that mature as we have today. But again, thinking as a person from today, I would have probably had an integration of my PLM system to my upstream and downstream system. So when I mean upstream and downstream system, it would be my neighboring systems to which the information can be transferred. Yeah. Upstream would be something like, if I'm trying, I'm so sorry, I'll just come back. Yeah, upstream would be something like I'm trying to fetch an information specific to my compliance on the product that is about to get launched. So when I mean compliance, there are a few rules that a government would actually regulate. So if you're trying to release a product to the market, it should have so much of halogen. It shouldn't exceed so much of halogen, or it should basically satisfy the REACH ROHS compliances. So all those information would be stored in something called as a compliance system. So even before releasing my product out to the market, I want to fetch those compliance information to make sure that the product that I launch is always compliant. So this is just one example of an upstream system. We also have downstream. So downstream would basically mean to say the information that actually gets into the next level or the next processing. Once after the complete processing is done in the PLM system. For example, my design work is done in the PLM system. I want to take it down to the production system. So my production system would be a downstream system. It can be anything, for example, SAP or ERP. So based on that, I can define as to what should be my upstream, downstream system, and what should be my information that should flow from my existing PLM system to the downstream system. So we'll also take a look into that in one of the coming slides. Next, better collaboration. So had there been an opportunity where we can form a team on a specific product. So one car, if I want to launch a car, it is not a project by itself. It is one entire program, yeah, because there would be a division mainly focusing on the development of the engine. There would be a division which is mainly focusing on the bonnet, or there would be one division which is mainly focusing on the chassis. There will be one division who would be mainly focusing on the infotainment system. So what I'm trying to say is each of these divisions would be having its own team. So when I mean team, it's more like a team in a sport. If I take an example, the Indian cricket team, it's not just the batsmen. The team is not completely filled with batsmen, right? We have bowlers, we have batsmen, we have wicket keepers. so on and so forth. So each of these personals in this team would play a major role based on the skills that they possess. Likewise, even in product development, we have a set of people who are actually dedicated to the things which they are actually proficient with. Yeah, so that's why you would normally form a team when you're trying to consider product development, right? You would normally form a team with respect to each of a product, and then try to we'll try to once after each of the task is completed, each of these members in the roles would be notified for their respective action to be completed, so that the product matures from one lifecycle state to the other lifecycle state. So we'll also take a look at that as well. And then more secure system. Like I said, I had given the example of Russia bombarding Ukraine, right? So we would like to have a more secure system. So in this case, we can have the option of storing all these information in cloud or in some other place where things can get more secure in that sense. Also, the other thing is send out the right information at the right time. There is not all engineers who are actually working should have access to the drawing or the object which we're actually working on. So only the right person should have the right access to the product at that right point in time. So we will also take a look at that during when we try to discuss the access controls. And then easier change management system. I'm just giving a check on time. Okay. So easier change management system. So with this, what I'm trying to mention is we should have a mechanism where we can easily propose a change. That is, a mechanism where we can easily create problem reports, change requests, change notices. So we will also take a look at that as well. Easier BOM management, bill of materials. For now, just understand that bill of material, I think most of you already know it, but for those who don't, bill of material is basically a collection of components, subcomponents that goes into the making of the final sellable item. So there are different type of bill of materials. For example, the engineering bill of material, which is mainly specific to the engineering side. We also have manufacturing bill of materials, which is mainly focusing on the manufacturing aspects of a product creation. We also have compliance calculation. Like I said, had there been a system where we can get all these compliance information, something like the upstream system where we can get all these compliance information before even launching my product, I think that would be a very important item in my product development. But the most important thing, once I have all these in place, the most important thing is I will reduce my cost, I will have shorter lead time, I will also have improved quality. So these are the most important thing which I'm trying to achieve or I'm trying to identify and achieve in my existing process. So even before getting into PLM, I think you might have, you may have understood, what PLM is all about, even before getting into the definition of PLM. So let's just, if you have time, let's just quickly get into the comments to see what, I'm not sure how we can actually look into the comments. Just a sec. I'm not sure if I can view the comments, what you have entered, but I think that's fine. I will certainly review your comments once after the presentation is done. All right, since we are actually limited on time, let me just come back to my presentation. So can you still see my presentation or?
Yes, sir, we can see that. What is a PLM? That slide we are able to see, sir.
All right, yeah, perfect. All right, so just to let you know, I mean, combining all these things, what is a PLM? So in simple terms, I mean, I really do not want to have, I just try to take the best definition from SimData, but in the most simplest of terms, PLM is basically the art of managing the product data, since the time of its conception, since the idea is conceived, to the different stages of the life cycle maturity until the time the product is being discarded. So that is the, I can say that in simplest terms, that would be the definition of a product life cycle management. So just to put that into perspective, let's just try to consider the life cycle of, a human being or a butterfly, which we have already learned in our school, during our school days, So the initial the butterfly would normally start off as an egg, and then it it rests as an egg for some time, and then it becomes a caterpillar. And then as a caterpillar, it would basically munch on so many leaves and plants, and then it would come into a phase called chrysalis or pupa, and then it will rest as a pupa for a few days, and then ultimately the adult emerges. Yeah. So just like that, if you're trying to juxtapose this image to that of the product life cycle, it's exactly the same. You actually first conceive your idea. And then once after you conceive your idea, so that would you can basically start off with the requirements. Yeah. So you basically start off with the requirements. That is, the marketing team will identify what the market actually wants or what the competition is already providing. So they would start off from the requirements, gradually come into the concept phase, or the phase where initially the idea is beginning to starting to take shape. They will try to get many approvals for that even before getting into the design and engineering, before trying to create, and then they will try to create a prototype of it, and then so on and so forth. So every organization would have a different stage of the product life cycle. So normally the initial stage would be the concept, or the marketing stage, or the idea generation stage. So that would be the initial stage, and the final stage would be released in most of the cases. Once after the product is launched in the market and everything is done, if you feel that product is no longer valid to be in the market, you can also discontinue the product, or you can actually take the product for an obsolescence. So that is the general understanding of PLM. So whenever the term PLM comes to your head, or if it is being asked in any interview, you can just always think about the life cycle of a butterfly. So you can always translate egg to be the idea that you're trying to conceive. You can think of caterpillar as a prototype, and then the chrysalis or the pupa stage can be identified as a place where you're trying to implement your plan, or to implement your proposed change. And then the emerging of the adult can be identified, or can be translated as the product that is being sent out to production, or the product that is being sent out to the customer. Yeah. Now, coming on to the life cycle in PLM. Like I said, it would normally start off with the concept state, and again, depending on the organization, every organization would basically suit itself. I mean, some organization would have a complex life cycle template. Few other organizations would have a very simple life cycle template. This, I can say, this is something which is taken from my organization, where we normally start off with the concept phase, where it is still in the design work state, or it is still in the it's still is stuck as an idea, and then the design engineering team will basically look into the idea, try to have that conceived, and then they would bring it to the design phase. So if you want to mature from one life cycle state to another life cycle state, there is a process that has to be followed. Like I said, if you remember, if I just come back to my process, if you remember, I was talking to you, I think it was in the collaboration phase. I was talking to you about the drawings that are being physically carried to their immediate managers for approval, right? So that can be automated at this phase, yeah? So in this phase, what happens is, once after the design engineer or the designer basically completes his or her work, he can actually complete his task assignment, and then a task would automatically go out to a functional reviewer to see, to let him know that the drawing is already completed. If he's okay with that, he can either approve it, or then if he's not really happy with it, he can actually opt to go with a rework, or if he's not really interested in the idea, he can directly reject the proposal and then close the task. So in this, you can see here, each of these process flows. So this is just a random example, what I've actually given. There can be multiple different flows depending on what the organization actually wants to. So for example, here, the object is in the review state, yeah? the object is in the review lifecycle state, and the object is basically logged for editing. No one can actually edit at this phase because the object has actually gone out to the person or gone out to the manager for his or her review, and that's why the object is actually logged for editing. So at this point in time, he would just check if it is okay to go ahead for an approval, or if he's not really happy with that, he will opt to go with the rework. So all these, right, would basically happen via email communication or a different type of task assignment. So that's not really, I mean, we really don't have to have the reviewer or approval to be physically present to approve the drawing, because these drawings are the CAD objects. He can basically review them on the go. Yeah. So these managers or these reviewers could be quite busy in terms of their work. They would be traveling to another place. So on the go itself, on their mobile devices, they can get to see the task assignment. They can open the task. They can see what the design is all about. What were the changes that were being approved and how it is getting implemented. If they're happy with that, it's just a click of a button. You can see, right, how simple things are. So it's just a click of a button. He can either opt for a rework, or he can either approve the task so that the task can mature to the next step and go for a released lifecycle state. So what I'm trying to say here is, if you want to mature your product from one lifecycle state to another lifecycle state, there is a set of process called as workflows. This process are basically defined inside something called as workflows, and the workflows would have designated team that basically sends out these task notification to designated person to basically complete his or her task. So that's the whole concept of lifecycle. Yeah. So even if you're going for an interview, when if someone asks you about the lifecycle of a product, you can always think that it always emerges. It starts off as an idea, and then it ends up as a product that goes out to the customer. Or in some cases, it emerges as an improvement idea, or that improvement idea would in turn create a new revision of the object that is already being procured, which is already being produced. All right, let's coming to the next slide. Let's talk about collaboration. That's also very, very interesting, because during the start of the session, I said, there are 5 different elements with respect to PLM. One is people, the other one is process, the other one is collaboration. So, collaboration in that sense is very, very important. And the other one is security, and then, the product data. Now, talking about collaboration, like I said, if a team has to be successful, I had given an example of the Indian cricket team, right? If the team has to be successful, we should have, if we have all batsmen in the team, yeah, there is a highly likely chance that we might actually lose out on all the matches, because even if our batting is good, we might actually fail out. We could probably lose on the bowling aspects. So that's why we should have an equal balance of bowlers and batsmen and fielders in the team. Yeah. So likewise, even for a product development, we should have a proper set of team defined. So that's how important collaboration is with respect to a product development. Like I said, there are multiple types of roles, and each of those roles would be getting their respective task assignments. For example, like I said, the design engineer will receive his or her task. And in those tasks, you would have certain instructions as to what should be done with respect to that product. So if you want to implement a change, it would basically start off as an engineering change request, yeah, and that engineering change request will basically have as to what has to be changed. So this would basically go through an approval cycle, and then once after the approvals are done, it comes to the design engineer, and the design engineer would be notified as to what exactly has to be done with respect to implementing the change. So what I'm trying to say here is each of these designated roles in a team would be having their own designated tasks. So this is predefined inside a workflow. Yeah, you do it once, and the same process would follow across the entire organization, because you're in terms, you're also trying to standardize the entire release process. Unlike if you have multiple approval processes, right, then that would basically create a chaos in the system. So if you're having one approval and release process, I think that would basically standardize the entire process within an organization, and that would also be error-free. And like I said, less of error would mean less of cost. All right. Now, like I said, roles and task assignments is very, very important, mainly to mature the product from one lifecycle state to the next or subsequent lifecycle state, ultimately releasing the product for manufacturing. Systems. Multiple systems will be involved. Yeah. So this would also, this is also slowly getting into the process of IoT. Yeah. For those who are actually thinking, where is IoT in this? So yeah, here we have it. So when we have multiple systems involved, there can be chances that, at least for now, for today, most of the organization, what I'm trying to talk about, has certain set of manual intervention. Yeah. For example, I'm trying to release my product. Yeah. My product is in the release lifecycle state. When I just come back and say it is in the release lifecycle state, and what happens is the downstream system, that is the manufacturing system, will get a notification stating that the product is already released. So basically the system is communicating to another system stating that the product is already released in the engineering domain. So you can start creating the manufacturing bill of materials and then start producing this product. Yeah. So there is obviously, I mean, if you're trying to consider today's scenario, right, there is obviously manual intervention in terms of creating MBOMs or, in creating many other attributes, which is aiding to, the manufacturing process. But going forward, with the with the advent of interconnected sensors or interconnected applications and systems, it's not really needed for us to be a part in the system, because now this would be an ecosystem by itself. Once after the part is released, like I said, the manufacturing system would try to look into the ERP to see if there is how much demand is actually there, and based on that, the ERP system will check if enough materials are there or not to produce that item which is getting released. So if the materials are not there, it would automatically send out a request to the procurement to fetch out, to get these or to procure these raw materials to initiate the manufacturing. So in this process, you can see systems are actually talking amongst themselves, eliminating the need of any human intervention. This might sound a little bit creepy, but going forward, this is how it's going to work. I have literally seen this when I was working in SKF, where they were actually making this as a concept. Once after the product is released, it would automatically create an EBOM. It would automatically create a manufacturing bill of materials. It would see as to which production line is free based on the occupancy of the production line and in which plant, and automatically these design would be transferred over to a machine which basically converts these designs as codes, and these code would ultimately start the CNC programming, and then will eventually start producing these items automatically. If you also were to get into one of these factories, these smart factories, right, you also get to see there are very few humans who are actually interacting with the machines. You can see a lot of robots also making their way through some yellow lines to each of these CNC machines. So at times we might actually feel a little bit worried that our jobs might go away in the future. But yeah, going forward, this would basically, as an organization, it would actually create a lot of value in terms of eliminating a lot of errors and also improving productivity, because that's the most important thing for any organization. All right, now speaking about bill of materials, I think I already covered this. Like I said, the components that actually goes into the making of a product, it can be, you can also consider, if you're trying to make a cake, right, you have so many ingredients that actually goes into the making of a cake. That is, you have the flour, you have sugar, you have the essence, you have eggs that goes into the making of the cake. Likewise, for a product also, it has different set of components, sub-components, sub-assemblies that goes into the making of it. And that is normally called as a BOM. And again, if you want to release these BOMs, right, in some organization, they would make it as a mandate to make sure that all of these parts that are getting released is compliant. So when I mean compliant, it is basically adhering to all the compliance regulation of that specific country. If I'm trying to release a product in India, I should basically comply with the regulations that the Indian government has actually set. So all these compliance is actually, either the supplier, the material supplier should be giving us, or it would be in a common platform where we have all these compliance information. So what happens is when we're trying to release the part, the system would basically try to fetch this information from this compliance system and then have that attached as a compliance information on the component level or the material to which the component is being added, so that once when you're trying to release the sellable item, it is always compliant and it is always adhering to that local regulations. So that's how important collaboration is with respect to the bill of materials as well. All right, now talking about security. Sorry to be rushing. I'm not sure because since we are actually limited on time, we're already 3:07. I think we have few more slides, few more interesting slides coming up. So yeah, I'll try to take all of your questions at the end of this session, and then we'll try to have them addressed. All right, now speaking about security, security also is a very, very important thing with respect to product development. Like I said, the designers, the task should basically go out to the right person at the right time, and only the person who has access to the task should be able to modify the task. So when I was in the concept stage, right, or when I was in the design stage, only designers will have access, or only designers should have access to the work that is being done. None of the other participants from the team should have access, or anyone outside should have access to this object, because because of this, if we have a total secure environment, then we can actually keep the changes to ourselves even before releasing the product out. Yeah, so we are actually working on something, and that's why it is actually logged to be viewed by others. So that's why at this phase, only the designers should have access to it. Again, it depends on different organization. And then once I'm actually done with my design work, once it goes to the review lifecycle state, I would say the designers will not have access at this point, because now the design is done, right? Now the reviewers are basically reviewing what the changes are, or what the designers had actually done. So obviously designers are nobody else from the team or from the product development team will have access to the reviewers' information. So reviewers will have access to it. They can review what is being done. They can review if everything is okay or not, even before they can give their approval or denial on the task that they basically receive. And again, the reviewers also will not have full access to the object, because they are not the actual designers. They are not supposed to do any work on the product. Their only task is to open the drawing or to open the CAD and then review if everything is okay or not. So what I'm trying to say here is, based on the life cycle where your product is currently in, based on the life cycle, the access is also defined accordingly. So that is what I mean by right information at the right time and to the right set of participants. Yeah. So this is also a very, very important thing in terms of PLM. And then talking about the different release processes, I think this is something which I've already covered. One is the first-time release. That is, first time you basically conceive the idea, you develop your product, mature your product from the concept state, design, review, approve, you get it released. So this would be the first version of the release, the product that was being released. You can take this as the first generation of Creta. And then, like I said in my previous example, Kia Seltos just came into the picture. Of course, since Hyundai is a parent, they already knew that Kia was already having plans of entering India. So that's another story. But yeah, they realized that Kia is actually coming to the Indian market. So they already started off with their work. They try to take a look into what Kia had to offer, and then they try to work on the newer designs or any other existing designs in the old market, and then they try to introduce it to India. And then what happened for the first one, the first time release actually went through something called as an engineering change request. Like I said, anyone in the organization can have the privilege of creating something called as a problem report. Yeah. So once they actually create a problem report, the respective managers will review the problem report. They would see as to what would be the challenges or what would be that product improvement that can implemented in the existing product to release a newer version, which is better in terms of what the competition has to offer. Yeah. So anyone can create a problem report, and this problem report would translate to something called as an engineering change request. So engineering change request is nothing but a formal request defining as to what the change is all about. Yeah. And then what are those objects that are getting affected by the change. And then we also identify who would be those team who should basically work in that specific change. So these are some of the items that we basically identify inside something called as an engineering change request. So every engineering change request is, it's only a mechanism by which you can actually request a change and get an approval for a change, and that's it. If you want to have a change implemented, we have something called an engineering change notice. So this would be a formal approval or a formal mechanism or a medium through which you can have the change implemented. Yeah, so that is what you mean. So that is something what you mean by engineering change notice. So it basically goes through each of these process again, gets the approval, and then in the engineering change notice, it will come back to the concept state. So remember, when the product is already in the release state, no one have access to it to edit it because it's already out there in the market. It is already under production. Yeah. So no one will have access to edit a product that is already under manufacturing. So when you actually go through this change process, you actually create a new revision. And then when you create a new revision, the product will come from the release lifecycle state. It will come back to the concept state. And then obviously the designer will be notified, about the approved changes. And then it'll, go through this lifecycle one more time until it releases the latest version of the product. So that would be the latest version of Creta that we are having right now. Yeah. So this is nothing but the NPD release. I mean, NPD release would be the first release or new product development releases. The sustaining release would be the revisions. Yeah. On the NPD, you actually create a new revision and then you actually release it again, basically with an improvement idea or an enhanced product or fixing some of the bugs that you might already have in the existing system. All right, now coming on to the most interesting part. We actually talked about, coming back to our old example, AMC. Yeah, you can see that, the people were actually we had an advent of CAD at this place. And I just wanted to let you know that, this company, this is actually a true story that, AMC was the first company who actually started with the implementation of PLM and improvement in the processes. They had, got a very good, improvement in terms of reduced cost, shorter lead time, and improved quality. And later on, AMC would be acquired by Chrysler. Yeah. And, the first thing what Chrysler had done back then was to, adopt this technology to their organization as well. They found this process improvement to be very, very effective. And then they also had this process improvement implemented to their organization as well. And just to let you know, the first product that these guys released, once after the PLM was actually implemented, or once after the process improvement was actually considered, was, I'm not sure if you know this car. It is called the Jeep Grand Cherokee. It is kind of, even to this day, it is one of the highest selling cars, the Jeep Grand Cherokee. You do not have it in India yet, obviously considering the price point, but in US and European market, you have, even to this day, they sell the latest version of the car, obviously. Yeah. All right, now let's just come back to our very interesting slide. That is the future trends in PLM, digital twin. All right. Now, like I said, in our old factory, we initiated the process of CAD, and then during those days, when I was in my CAD realm, I was only into dimensions. I was just entering the length, the breadth, the width, and that's it. It was just letting me know as to what the product has in terms of its dimensions. Later on, it got improved, and then it tried to accommodate more product information. For example, what is the material that goes into the making of that product? What are the properties of the material? Or and the compliance information, like I said, and many other data. And then as you had more and more of these data coming into the product in the virtual world, it started getting more and more realistic in that sense. So you can literally compare the virtual product to that of the one that is already available in the physical world. But one disadvantage was we literally did not know as to how the physical product or the virtual product would behave in a physical world. So what they did was they tried to attach a host of sensors, and then they try to put this physical object in the real world scenario to capture those attributes as well. So like I said, now what started off as a 2D drawing or a medium to only define the dimensions is now slowly moving, is trying to gather more and more information in regards to the product. And it is trying to reach a point where it's trying to acquire all the properties that a physical product already has. So there is nothing but digital twin, but how important it is in the physical world or in today's world. For example, if I want to launch a product, I would obviously, or if I want to launch a car, it should obviously go through an NCAP crash testing, right? So right now it is mandatory in many countries to have the crash testing done. But if I have a proper setup where I have the exact replica of my car as a digital twin, that is not just replicating on the dimensions, but also replicating on the properties and also replicating on how my physical product would behave given the external stimuli, like based on the temperature, based on the obstacle in which my car is bombarding with. So if I have all these attributes, instead of doing a physical crash test, I can literally do the crash test in my system and then try to identify how safe my car is. So with that, I can actually save a lot, in fact, a huge amount of money with respect to doing all these crash tests. So this is just an example what I'm trying to give. There are a lot more examples. So I would say, you can also try to get into YouTube, try to identify, you can try to go through some of the, the researchers that are happening in digital twin technology. It is really, really mind-boggling, I can say. All right, now coming on to metaverse. So if you look into, one of the things which I just mentioned, there is collaboration. Collaboration is also a very, very important thing in PLM. So this is just, I think I'm kind of exaggerating this a little bit, but going forward, this is something which I actually foresee. I've also read articles from SimData and, an article from Oleg Shilovitsky, which also mentions about the emergence of metaverse for collaboration. For all those who doesn't know what metaverse is, this is a future trend. It's all about virtual reality. Once you have the digital twin, or once you have the virtual world which you have already established, you have an opportunity to get into the virtual world by yourself, and then you have an opportunity to explore things then and there. You can sit at the comfort of your home, wear a heavy, the IR camera in your eyes. I'm sure that there is certainly going to be a discomfort because those gadgets that you wear in your eyes, right? So that is something which that's the window to your virtual world. You actually get into the virtual world. You get to see a host of virtual people. You get to see a lot of virtual shopping malls where you can actually purchase NFTs. You can actually purchase any product that you want to. You have You have virtual places where you can actually do a collaboration. You have virtual concerts. So this is going to be the future. It obviously might make you lazy, but again, it would make you at the place where you're sitting at the comfort of your home. You can go to a place which is literally virtual in every sense. So if I'm trying to collaborate, coming back to the collaboration in the PLM front, I was talking to you about team, right? For a product development, there would be a dedicated team. There would be a dedicated set of personnel who are actually expertise in their own field. What if we had an opportunity where we can actually, collaborate? The product engineers, the manufacturing engineers coming together, the quality engineers coming together, trying to review, coming in a common place where it is more secure. I'm talking about the metaverse, where it is more secure. They have an opportunity to review what the drawing is, to review what the changes are, and then upfront they can also give their, their agreement on the proposed change or the proposed introduction of a new product. I think it would have been much good, right? It would have been pretty good, right? Because because these days things are getting outsourced to different countries. So if you want a localized place where you can actually meet all these resources in one place, I would say it would be a metaverse. You can literally get into a meeting room, you can review the drawings, you can explain as to what the design changes are, or you can explain the new features, or the marketing guy can explain to the design engineer as to what the requirements are. So I think it is going to be, it is certainly going to be a thing of the future. And I'm sure that most of the PLM vendors are also thinking on how to get into the metaverse technology. So metaverse is also a very, very important thing when it comes to the concepts of PLM, mainly focusing on the collaboration part of it. Now, coming on to IoT, I think we already discussed, right? The upstreams and downstreams. So that is just one example. So when I mean IoT, there has to be seamless communication. So with the advent of countless number of sensors that we have, sensors that are being networked, applications that are, speaking to machines that are speaking back to the applications. I think we would have an integrated ecosystem, which would be, which would be the most efficient process which you can already imagine. So IoT, when you're trying to have these integrations in place, when you're trying to have these systems and machines collaborate to each other, I think we have a platform called an IoT. So with this, we can also reduce a lot of lead time. We can also improve the quality of the products that are being produced. All right, now this is about the PLM. Of course, this is not the complete picture of a PLM, but I believe that I have introduced you to it's just the tip of the iceberg. There are a lot more things to cover. So you can you can actually get into YouTube or any other websites where you can get into Oleg Shilovitsky's website. It's called PLM Twine, I guess. I will just let you know as to what that website is. You can just go there if you're trying to if you would like to know more about PLM and the emerging trends with respect to PLM. You can just probably get into that website, and I think you would have a host of information to know more about PLM and things like that. Now, the major vendors in PLM, so these are basic solution providers, or major solution providers that you have in the market today. We have Teamcenter from Siemens, Windchill PDM Link from PTC. PTC is the full form for Parametric Technology Corporation. We have Enovia from Dassault Systems, SAP PLM, Aris PLM. So these are some of the the major players in the market. So an organization would basically look into their business requirement. They would see as to which of these PLM applications would be their best match, and based on that, they would basically define as to who should be their the PLM vendor. Now, coming on to the roles that you can actually opt to work for in PLM. So there are different roles which you can actually opt to be working in the PLM domain. For example, if you're looking into each of these service vendors, right? Siemens, PTC, obviously there has to be a developer who can actually develop the application. Yeah. So the developer and the customization expert should basically know, should be good at coding. Again, the customization expert is not really needed to be a part of these organizations, but they would be a part of service industries, like majorly be a part of service industry, and also certain OEMs as well, based on the customizations which the company needs. I know companies which literally, although Winchell PLM is their, is in the background, they still have UIs that are actually created in such a way that we think these are customized applications only for their industry. Yeah. So we also need a customization expert who can, create applications adhering to the existing PLM out-of-the-box system to make sure that the application matches to the business needs. We also, there is a need for testing individuals. Obviously, with the, when we have software development, testing is also a very, very important role. I would say the testers should be, very adept with the functional process on how the out-of-the-box functionality works. They should also have a fairly good understanding on how the business works and to understand as to what the business actually wants. Yeah. There are functional consultants and business analysts. Functional consultants are mainly functional experts. Yeah. With respect to the out-of-the-box solution or the customized solution, which these guys have already provided to an organization, they would be an expert considering those applications. So they would be mainly in the requirements phase, or they would mainly be a part of the support team, because support is a very, very important phase in a PLM organization. They would basically act as a first level support to the functional consultants. Business analysts are more into the business side. Yeah. So they have been there, done that. They exactly know as to what the business wants. And they also have a fairly good understanding as to what the system has to offer. Yeah. And based on that, the business analyst would mainly act as a liaison between the business and the service provider. So that's a main function or the main responsibility of business analyst. Project managers. So, PLM is not there in all the organizations, to be honest with you. There are organizations who are still working on, with the drawing boards. So some of these organizations, or most of the organizations, are actually thinking over to getting into the PLM arena, and that's why there is a huge need for project managers for implementing PLM in their respective organizations. So this is not a simple feat, mainly because project managers are mainly responsible to to overlook the entire implementation of the project. That also includes the upstream and downstream systems as well. So these are some of the roles which you can actually think of if you are actually interested in getting into the PLM domain. Yeah. And also a word of advice, you can actually get into, you can make use of LinkedIn, because LinkedIn has a very good source of these type of information. You can try to check as to who are the PLM resources who are actually working in different set of organizations. Get into the profile. I think it's fine. You can get into the profile, because that's the main intention of having LinkedIn, right? You can get into the profile. You can see what those guys have actually done with respect to in different organizations that have actually worked, and what were the certifications, or what were those skills that they had actually acquired when and to get them in that position which they're actually working on right now. So yeah, I would say LinkedIn is actually not endorsing me, but you can make use of LinkedIn, and I would like to say that this is a very, very good platform for you to have a good career advancement. Yeah. So hoping that you are actually clear about the concepts of PLM. Like I said, this is just the tip of the iceberg. Since we just had 1.5 hours, I think I have actually covered some of the most important topics, but there are a lot more to cover. If you think you have few other doubts that needs a clarification, you can just drop me a message on LinkedIn. You can just let me know what is the thoughts that you have, and then I will try to have that addressed at the earliest. All right. So, is there anything else that I should be covering which you are actually interested in? Or should we just, I don't know how it works. So Anna, should I just give it back to you, or how is it?
Anna ma'am, are you there, ma'am?
Yes, sir. Yes, sir.
Yeah, we will see the questions in the chat box.
Yeah, if students have any questions, they can put it in the chat box.
Chat box, yeah.
Or you can unmute and ask.
Or you can unmute and ask the questions.
So also all the students, please fill the feedback form. The link is shared in the chat window.
So I think there are no questions.
Okay.
Yeah.
So yeah. If you have any other questions, right, you can also get in touch with me in my LinkedIn profile. You can drop in your comments or thoughts. Like I said, you can also go through a lot of materials which is already available in the website. And then I think PLM is certainly an interesting topic to be explored. And one of them, a PLM is also something which will easily get glued to the upcoming latest trends. Like I said, metaverse, cryptocurrency, all those things can be would be a part of PLM going forward. All right. So if there are no other questions, I think I will just hand it back.
Sure, sir. Anna ma'am?
Yes. So there's one question. How is
Scrum
PLM related?
PLM related?
Yeah, Scrum is one of the project management techniques. So I think that would basically that would basically come during the PLM development phase or during the PLM implementation phase in any organization. Does that answer your question?
Swati, did it answer your question? Okay, she got it, I think.
All right. So so if there are no questions, I just hand it back.
Yeah. Okay.
I'll stop my presentation.
Karthik Sanjay, can you propose the vote of thanks for the session?
Yes, ma'am. Am I audible?
Yes.
Yes, Karthik, you're audible.
Good afternoon. I'm Karthik Naik. So I deem it my greatest honor and privilege to propose a vote of thanks for this educative event. So first of all, today's webinar, which talked about product lifecycle management and looking at it from a perspective of life cycle of a butterfly, provided a broader view on that and what role it plays in an engineer's career, and how hugely it is the concept of PLM has impacted and is impacting the world today, alongside the technologies like IoT and futuristic technologies like a digital twin and metaverse maybe. And on that note, I would like to thank our special guest and speaker for today's webinar, Mr. Tejo Thomas, Senior Business Analyst, PLM TE Connectivity, who in spite of his busy schedule lent his time and experience and knowledge and enlightened us about PLM and its importance in today's world. Much gratitude, sir. So, and also like to express my heartfelt gratitude to Dr. Vaibhav Meshram, Sir, Chairman, EC Department, whose endless support, encouragement, which made this today's webinar possible. And I also thank our organizers and coordinators, Professor Anna Marin ma'am and Professor Puneet sir, for their continued support and for arranging this event for us students, which allowed us to gain a deeper insights on PLM, which is also part of our curriculum. And I also thank all the participants and invitees here and my friends. And finally, I leave with you and with an inspiring quote from a greatest scientist from our own India, as Dr. C.V. Raman, who said, ask the right questions and nature will open her door to her secrets. So keep asking the right questions, and keep learning. That being said, I thank you again for your kind attention. Thank you, sir. That is all.
Thank you, Mr. Tijo, sir. Thanks a lot. Thank you.
Thank you so much. I mean, it was indeed a pleasure.
Indeed a
It was, this is the first time that I'm actually presenting in a college, and I would certainly consider this as a privilege and honor. And yeah, I'm really thankful for this opportunity. Yeah.
Sir, and it had created a lot of interest into this PLM domain, which we were not much aware of this thing, PLM domain, our students and as well as faculty.
Yeah.
So thank you, sir, creating an interest into this domain. Thank you so much, sir. Thank you for your precious time, and have a nice day, sir. Thank you, Anna. Thank you, Karthik. Thank you, Puneet, sir. Have a nice day, sir.
Thanks all. Have a nice day. Bye-bye.
Take care of yourself. All of you take care of yourself.
Bye.